Hey guys, Mr. Mises here, and here we go. Last unit in BC Calculus. This is a topic, a short video on parametric equations. So I just want to talk to you about what parametric equations are, show a few examples of just graphing one and then converting from a parametric equation into a rectangular and back. So here I've got points, I've got a curve defined parametrically, and what that means is I have it defined as another variable. So I have x defined as with another variable and y defined with another variable. Same variable. Usually it's a t. And in most applications, we're going to say t is time. So we've really got three variables going on here, where our x and our y are defined by a third variable, in this case t. So what we're going to do here is we are going to we're going to sketch this curve. Now we're going from -3 to 2, so I'm just going to put time as -3, -2, -1, 0, 1, and 2. I'm going to plug in my t into my x equation and my y parametric equation, and then come out with my x and y coordinates. So when I plug in -3 in there, I'm going to get 9 minus 5, which is 4. I'm going to plug these guys in here, and you can go ahead and plug this in here and get these as we go along. I'm just doing this so we can speed it up, but again, you're going to plug in t, you're going to plug that in right there, and then you're also going to plug it in right here, and you're going to get the values for y. Alright, so now that we have our x and y coordinates, where was I looking? I was looking over here. Now that we have our x and y coordinates, we're just going to plot those points. We're going to start with t equals -3. So we're going to start with 4 -3 halves. So, sorry about that. 4 -3 halves is going to be right here. Now it's a less than or equal to sign, so this is going to be a closed circle. And it's going to close circle at the end as well, which is going to be at -1. Well, let's just go through these points because it's kind of the trajectory we're going to go in, -3 to 2 in terms of t. So let's go to -1, -1. So that's going to be here. Okay, so then we're going to draw the curve there. Then we're going to go -4, 1/2, or -1/2, sorry. It's right here. -5, 0. -4, +1/2, and -1, +1. And so we're going to get a curve that looks something like this. Okay, so that's a parametrically defined curve, since we have x and y in terms of t. So let's go and see how we're going to change from rectangular, change a parametrically defined curve into a rectangular defined curve. So what I mean by that is we're going to change these x and y, these two x and y equations that are in terms of t, we're going to change it into one equation that's just x and y. All right, so we call that eliminating the parameter. So really what we're going to do is we're going to solve for t in one of these, and the easiest one to solve for t in is we're going to solve for t here for, okay, so we're going to do x squared equals 1 over t plus 1 because I squared both sides. All right, so that's going to be 1 over x squared equals t plus 1. And I'm just going to subtract 1 from both sides, and I get t. Then I'm going to take this and I'll plug it into my other formula. So we're going to use substitution here. So we're going to have y equals 1 over x squared minus 1 over 1 over x squared minus 1 plus 1. So these are gone. And I'm going to multiply everything by x squared, top and bottom here. All right, so I'm going to 1 on the bottom, and I'm going to have 1 minus x squared. All right, so there is my rectangular form, and I have to also see t is going to be greater than or equal, t is going to be greater than -1. So what I'm going to do is I'm going to plug that in here. And I'm going to get x is equal to 1 over root -1 plus 1. All right, that's going to be 0. So x has to be greater than 0. Well, the bottom's going to be 0, right? So we can't have that happen. That's why t has to be greater than or equal to or t has to be greater than -1. But in our case, x is going to be greater than 0, so that we don't have this situation here where we have a domain restriction or a domain error. Okay, so now we're going to go and draw this. So 1 minus x squared, well, that's just a parabola. That's going to be an open circle there, and that's a downwards facing parabola. And I could, come on, my Estes, you could draw a better parabola than that. Well, maybe not. Maybe I can't. Okay. All right, so something like that. Okay. Now, notice here that I draw an arrow, and I forgot to draw my arrows on this one. Going this way. And the reason I draw an arrow going that way is because that's where it says time is greater than -1. And actually what's going on is when I plug in values that are greater than -1, I'm actually going to be approaching this this y value here. So I'm actually going this way for t values greater than -1. In my previous example, right, we started at t -3, and that gave me this point here. So I'm actually going this way is the way that if you can think about something maybe traveling on your curve, that's the way it's traveling. It's going towards that point from -3 to 2. And for time, going this way. I think you get it, okay? I just want to keep repeating myself. All right, let's try one more here. And we're going to go ahead and eliminate the parameter and sketch our curve. Now, this one's a little bit different because it's got cosines and sines. So anytime you have cosines and sines in your parametric equations, you're going to square both sides. So we're going to square both of them. So we're going to do this. We're going to go x squared equals cosine squared. And we're going to go y squared equals 9 sine squared. And then we're going to add them together. So we're going to get x squared plus y squared equals cosine squared. Oops. Sorry about that, guys. Okay. 9 sine squared. Right, then I'm going to go y squared over 9 equals sine squared. Now, if we add them together, I get x squared plus y squared over 9 equals cosine squared plus sine squared. Right? So I added this plus this, this plus this. And what's cosine squared plus sine squared? Boom! It's 1. So I'm going to get x squared plus y squared over 9 equals 1. And we all know what that is. That is going to be a hyperbola. So, I'm sorry, not a hyperbola, that's an ellipse. Ellipse has a plus right here, right? An ellipse with a plus. So that's going to be an ellipse with a x radius, I guess you can call it. It's the minor axis of 1. And then this is going to go up to 3. And we're going to go ahead and put these together like this. All right, and it's 0 to 2 pi, so it makes sense to do that. And so in 0 to 2 pi, which way do we go? We go counterclockwise. So my arrow is going to go this way. Right? Counterclockwise. All right, so those are some examples of graphing parametrically defined functions, as well as taking parametrically defined functions and putting them back into rectangular ones. All right, we'll see you in the next video.